Hey team, welcome back to my channel. In this video, we are going to build a linked list and store unique random numbers. If you want to see more programming training videos from me, where every video teaches you what you need, that are easy to follow, easy to understand, proven steps that will make you learn, you will benefit by subscribing to my channel. I will not disappoint you.
Let's preview all the source code that makes this project work.
Here you can see the include files I have used, as well as the linked list struct command. Also notice, I created two global variables of type struct linked list to manage the root node as well as the last node of the linked list.
Printlist is the function that prints the contents of the linked list. Notice that I have two print lines, printfs, that are actually equivalent to each other. The function add item to list places the number into our linked list. And here is the main function where it all begins. The main while loop that controls the control of the app. The while loop that determines whether or not the item will go in the list. Let's dive into this linked list implementation of creating a dynamic list, a linked list of random unique numbers. Let's give it a whirl. So on line 6 and 7, we have done these two lines. Does anybody know what that's called? These are called prototypes. And what they do is they allow me to declare these underneath main. If I didn't do that, main would bellyache and say, I don't know what add items is. On line 9 to 12, I have the linked list structure. And notice I only have one column that's going to get the unique number and then a pointer to itself. And then using the same structure, I'm going to create a node called root and last of this same type. Now it all comes down to main, and we're starting with main. We're coming in and we're setting the count equals 12. That is the number of unique numbers I want to put in this linked list. And I have another video that teaches you about srand, and this just seeds the rand function so we get a unique start every time. I'm now creating another local variable to main called current, and I'm pointing root there. Root right now is set to null. Now let's collapse some of this code so we can look at this as a big picture. So here, I say while 1. What this means is while true. And I'm going to get out of this when m equals count. M is my counter of number of numbers I'm putting into this linked list. So as soon as this equals this number, 12, I'm going to break. I'm going to get out of this outside while loop. Okay, perfect. Now, as soon as I get inside this loop, I say int num is rand mod count. So this right here will produce all numbers from 0 to 11. That's what this will produce. And I'm going to create a boolean found, and I'm going to initialize that with false. Sometimes people call this a sentinel assignment. And then every time I'm doing this loop, I always go back and I set the root to be current. And remember, right now, root is pointing at null. So if current equals null, which is this is true, then I say found is false. Now because found is false, I don't even declare that, I don't even come into this else statement, and I come into this if found is false. Now at a high level, let's don't worry about what it does yet. I'm going to add that item, that number that we just created, num, I'm going to add it to this list. I'm going to then increment my local variable m, and then I'm going to print that list to the screen so you can see what's going on. Then I'm going to do a little test to see if I have to break out of this loop, and if not, I come back up to the top and I get the next num. And I keep doing this loop for count 12 times. Now I just ran the program and I printed every time I added an item to the list. So notice I added 2, 4, 7, all the way down to 8. This right here is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 items are in my linked list. And now what we're going to do is we are going to look at the actual how memory is, and we're going to only look through root. Now, I need to also show you kind of like the list itself so we can remember. Remember, it started with 2. That's how it started. Now, if you see here, my unique number at that root node is 2. And next actually points to another part of memory, and we can open that up and say, what are you pointing at? Notice the next number is 4. And then we can open that up, and then the next number is 7. Let's check with our source code, make sure we're on the same thing. So 2, 2, 4, 2, 4, 7, 2, 4, 7. Very good. Now, you'll notice here that when it's the next, see how it points at 70, and then here's 70? This one points at 4A0, that's 4A0. So next just points to the next memory address. It's not really a big deal. When we see the add method, you're going to see how simple this is. Now I need to warn you, this is not something that you just pick up. You are gonna have to practice, but once you practice, you will become the master. Let's do a few more here. So next is 10, and notice the address goes down to E8. I'll open that up. That goes down to 20. That goes down to 58, and we'll just keep going down. And notice the last number that is in the list here is 5 and then 8. So let's just keep banging. 5, 8. Now notice when we get to 8, its next pointer is null. There are no more numbers in our list. And that's what that means. And notice the one before it, it said, look at AD58. So here's AD58. Its number is 8. But its next pointer points at null. There's no more numbers. Now this right here is key to understanding linked list. And all it is pointing the next pointer at another address. You have to practice. You have to learn how to go debug like I've just done here. Step through the program and you will master this. So the first time we came through this loop, root was set to current and root was null. So we will execute this top from 30 to 33, only execute this once. Thereafter, we will only execute this while loop here. So what we do is root always sets current. So as we keep adding items to our list, we always begin at the root. Every time we get a new number, I go to the root and I start looking. Hey, are you my number? No. Hey, are you my number? No. I just stay inside this loop until we either run out of numbers or I find it. So here you can see that if that current unique number equals that next number, then I found it and then I'll break. Now, if this is not the case, like imagine this is 2 and this is, 10. So they're not equal. So then it comes down and says, hey, is that current node's next equal null? Now what this means is I only have like maybe one item in my list. So found is false. My first number was 2. We can look at this list again. Imagine here, my first number is 2 and the next is pointing at null. So I know that only 2 is in my list. So what we have to do is break out of here and then go add 4 to my list. Now, if this is not that number and current next is not null, then what I do is I say current equals current of next. Let's look at a linked list here. So notice this next pointer, and I come over here to this next, notice that it says 8570. Do you see that's the address of the next memory address? And then when I'm on this line, that next is pointing at 5AA8. So I come down to the next address. So next is nothing more than an address in memory. Perfect. Now I keep doing that and I come back up there and I say, hey, is that next memory address that number? Yes or no? It's possible I found it, because there's dupes, the rand function does not generate unique numbers by itself. We're doing it for it. Now, right here, we are staying inside of this loop until this either evaluates to null, that means like I've run out of numbers, or I find it. That's what this loop does. Now when I'm in that loop searching for does it exist or does it not exist, if it's found, I come down here and I only do this adding if found is false. That's it. I don't increment my counter because it's already in my list. I found it already. So I come back up here and then I get another number. And then I come and I do the same loop again. I'm, just this thing just keeps generating numbers. And I'm trying to get unique numbers. So I keep staying inside of this list and I always reset my pointer current to the root. And then I just walk that list. And then, it's possible I find it again. And it's like, nope, that's no good. So I don't execute this. But when I come in here and I say found is false because I went current next is null, that means I have to add it. So now I'm into this little block of code. And it says, if found is false, add item to list, and I'm going to pass in current and that number. Then I will increment m, that is my counter of number of unique items, and then I will print that list. Printing that list became very, very beneficial to us because we saw how it was building the unique numbers for us. So let's now go look at add items to list. So when found is false, what that means is that number is not in my list. It's time to add that to the linked list. So I'm going to be passing in the current node and that number. Let's step in there, F11. Now in F11, what we do is, so I passed in that current node, I have the number, and what I'm going to do is I'm going to allocate a new piece of memory. And I don't know where it's going to come from. But this malloc command is going to go the size of this, and it's going to give me that many bytes. This right here, a struct linked list pointer, that's giving me an address. So last will be some address in memory. Now it is quite possible that I have run out of memory, so I kick out an error message that says no memory is available. Notice here I'm using printf, and I'm sending it to standard error. Then I exit the program. This is a pretty big problem. We have to look into that, right? So notice that if the root is null, well, this is like if the program is just starting. And then what I do is I set that root to equal current equals last. So both of these get this value. Else, this node that I'm sending in's next gets this next value. Let's look at the linked list again. This is some beautiful code. So notice here on this first one, my address is 6468. And imagine that it was null because I only had one thing in there. But when I generate that line right there says I just made this address. This is like last. And see how it says 64A0? Then I actually put it back into this value. So I made this one, and then I go update this one, and I say, hey, this is the next node. And that is what this one does right here. I send in that current node, and then I set its next pointer to this thing I just created. Then what I do is I take that number that we passed in, and I assign that to unique number. And I set its next pointer to null. There are no more numbers. We are inserting these numbers into this linked list always at the tail end. Now, you'll notice that I got these comments here, and what I did is I wanted to show you that there's two ways to execute this line. This is the line that I kind of prefer, but some people prefer this way of doing it. And this is equivalent to this. And as far as these next two lines, this is equivalent to line 94, and this one is equivalent to line 95. Now that I've added the item to the list at the end, I'm going to increment my m, saying, oh, okay, I've got another one. I wanted 12, now I have 3. Now I'm going to print that list so you can see it. So for instance, this is what that command does right here. I print out the list for us so we can see it. It's a nice debugging tool. Now let's go take a look at print list. Notice that I'm sending in the root node, and let's go there, definition, and here we go. So I send in the root node, and this root is local to this variable. So then I say, hey root node, I want you to equal current. And then I say, while current is not null, do this list. So notice here, I say, I get the root node, and then I say current, I'm going to point at unique number, so it's going to print out 2. See how it prints out 2 here? And then I say, hey, current, you equal current of next. So I take this number here, ADC8, and I say, hey, ADC8, send that to current. So now it drops down to ADC8, and the next time I'll print out 8. And I just stay inside this loop. And when I get at the end, current next is null. So then current is null. And then when it comes up here and it says, if current not equal null, well, now it equals null. So I break out of here. And that's how print list works. Let's make sure we understand that last one. When I am at that last node and I say, current equals current of next, notice I just printed 5 and it says, hey, I want you to go down to 5.8. So when I'm at 5.8, its next is actually null. So when I come up to the top of that, current is null. And that's how that got set. So a linked list is nothing more than following memory addresses. And there you have it, team. I cannot wait to hear back from you and telling me that you have mastered this linked list. This is great news. See you in my next video.